A question often lingers in all our minds. After all, both buildings and bridges stand upon a foundation. While the foundation for massive skyscrapers can be constructed quite easily on solid ground, how is it possible to construct a foundation deep beneath the ocean, one capable of supporting an entire colossal bridge? Hello, friends. As civilization advances with the passage of time, flyovers and bridges are being constructed to facilitate connectivity between distant points. However, the true challenges of bridge construction arise when the structure must be built over water rather than on land. While engineers already face formidable challenges when building bridges on solid ground, they encounter difficulties 10 times greater when the construction takes place over water. Building a bridge over water requires calculations not merely down to the inch, but down to the very millimeter. This is because even a minuscule error of a single millimeter could result in the loss of thousands of human lives. Notable examples include the Tacoma Narrows Bridge in Washington, USA, and the Millennium Bridge in London, instances where even the slightest engineering miscalculation led to financial losses amounting to millions. In today's video, you will discover how engineers overcome these daunting challenges to construct massive bridges over water. Welcome back to another brand new episode of the Deep Mystery Channel. When it comes to constructing the colossal bridges that span across bodies of water, the single greatest challenge facing engineers is the water itself. Almost every day, we cross countless bridges as we travel from one city to another, yet few of us ever truly notice the masterpiece of construction and the exquisite engineering expertise that lies hidden behind these mighty structures. Constructing a bridge is a far more arduous task than erecting even the tallest skyscrapers. This is because the structural load of a building remains static, whereas the load on a bridge is never constant. A bridge must withstand hundreds of thousands of units of load every single second, and these loads are in perpetual motion. Whether it involves building a residential home, a towering skyscraper, or a bridge, one element remains common to them all: the foundation. Just as it is impossible to construct a building without a foundation, it is equally impossible to construct a bridge without one. But herein lies the central question. Since the foundation for a deep-sea bridge lies beneath the water, how is it actually possible to construct a foundation deep within the ocean depths? How are these bridges constructed amidst the currents of the ocean? How do bridges built over the sea remain so robust, even after overcoming such immense challenges? Even massive waves cannot cause these bridges to sway by a single inch. Before constructing a bridge over water, an engineer's primary task is to measure the water's depth. They must gather precise information regarding the nature of the soil at the seabed. Professional scuba divers are deployed to observe whether the underwater terrain consists of rocky ground or sandy soil. If the water is shallow, both the cost and the labor required are significantly reduced. However, if the water is deep, the construction process becomes not only expensive, but also poses a serious risk to the lives of the workers. Once the conditions of the seabed have been assessed, the first major challenge is determining how to drain the water. Regardless of the water's depth, the absolute priority is to clear the water from the specific site where the foundation is to be laid. But how is it possible to remove such deep water? Engineers have devised 3 distinct methods to accomplish this task. Method number 1, the Cofferdam. The Cofferdam is a traditional technique. In this method, a massive embankment of soil is piled up around the designated construction site, rising high enough to breach the water's surface. By creating such a barrier on all sides, a watertight enclosure, essentially a dry pit, is formed. Subsequently, all the water within this enclosure is pumped out. Once drained, construction work can proceed with relative ease within the confines of this barrier. However, this traditional method was fraught with complications. Occasionally, the immense pressure of the surrounding water would cause the earthen barrier to collapse, allowing water to flood back into the site. Consequently, workers utilizing this older cofferdam method were often compelled to work while facing grave risks to their lives. Today, however, this method is executed differently. To prevent water from breaching the barrier, as it often did with earthen embankments, modern cofferdams are constructed using interlocking steel shields instead of soil. Essentially, these steel shields are driven into the seabed, one by one, using specialized machinery. In this manner, a robust block is created, from within which construction work can be carried out with great ease. Method number 2. Caissons. In this method, the foundation is initially constructed in a dry area. Subsequently, it is transported to the bridge construction site by ship and installed. However, the challenge for engineers lies in lowering the constructed foundation beneath the water. This is because these foundations are box-shaped, featuring a solid block at the bottom, yet remaining open at the top. If simply placed on the water's surface, they would float much like a glass vessel. To prevent these foundations from floating away, engineers employ a specific solution. If the water is sufficiently deep, large ships are used to deposit and fill the underwater area with rocks. The caissons are then lowered, typically with the aid of cranes, and positioned atop this bed of deposited rocks. Finally, concrete is poured in from above. In this way, a sturdy pillar is constructed. But the question remains, what happens if the water is even deeper than that? In such situations, a third method of foundation construction is adopted: battered piles. In this technique, massive iron pipes are first transported to the construction zone by ship. The next objective is to drive these massive pipes deep into the seabed. But how is such a feat possible? After all, these colossal pipes weigh in excess of 1,000 tons each. They are by no means lightweight objects. To accomplish this seemingly impossible task, specialized hammers are utilized. These are mounted onto ships and brought to the construction site. The pipes are then driven down, hammered repeatedly until they are embedded so deeply that even the ocean's most powerful waves cannot cause them to sway by a single millimeter. With a robust foundation now firmly established beneath the water, the actual construction of the bridge can proceed with relative ease. Having learned about these methods, you might be tempted to think that building a bridge over water is a simple undertaking. However, the reality is that this task is thousands times more difficult than it sounds. Constructing a single bridge takes many years to complete. Moreover, the process frequently results in injuries to numerous workers and, tragically, often claims lives as well. Thus, building a bridge over water is no ordinary feat. Let us now turn our attention to some of the world's largest bridges that have been constructed over water. Number 1. The Lake Pontchartrain Causeway. This bridge was constructed in 1956. It is located in the United States. This bridge spans a length of 38 kilometers. It is listed in the Guinness Book of World Records as the longest bridge built over water. Number 2. The Manshik Subway Bridge. Constructed in the U.S. in 1979, this bridge measures 36 kilometers in length. Number 3. The Wuhan Metro Bridge. Located in China, it extends for 37 kilometers. It was completed in 2017, and its construction took a total of 13 years. Number 4. The Beijing Grand Bridge. Built in 2010, this bridge has a total length of 48 kilometers. Number 5. The Danyang Kunshan Grand Bridge. This is the longest bridge in the world, yet it was constructed in a mere 4 years. The fact that this bridge was constructed in such a short time frame left everyone astonished. Its construction required approximately 10,000 workers who labored on the project from start to finish. I hope you learned something new from this video. If you are new to the channel, please be sure to subscribe and honor me with a like. For now, I bid you farewell. I look forward to seeing you again in the next episode.